Hi, everybody. We're going to talk about indoor air pollution today. And this is a pretty big concern, especially for newer built houses. And I think this kind of ties in pretty well with a lot of what we've been talking about with insulation and air sealing and vapor control and stuff like that. So, titled this slide, Houses Need to Breathe. And this is something that you guys are going to hear throughout your career, okay? And it's true. It is a true statement that houses need to breathe. But what we want for a house to breathe is we want to vent it properly. Okay. We want to control the ventilation that's occurring inside the house. Okay. As opposed to what most people mean by houses need to breathe, which is do a crummy job of insulating it and leave holes all over the place and don't air seal it. Okay. That's kind of the opposite of what we want to do. We want to completely air seal the house, have some good thermal control, and provide ventilation, okay? So when we talk about indoor air pollution, this is a buildup of gases, particulates, microbes inside the house that are essentially making people sick, okay? This is a fairly recent phenomenon. I'd say, since the 70s, this has been a problem. Okay, and we've seen an increase in asthma, allergic reactions to all sorts of different things. And a lot of this appears to be related to air pollution inside the home. Okay, and so there's a couple things that have happened here. The biggest one being in response to the energy crisis in the 70s, where all of a sudden energy prices skyrocketed. Okay, we responded, the United States responded by developing our own domestic supplies of energy and also mandating that buildings and vehicles consume less energy. Okay, so the way we responded with buildings was let's tighten up the envelopes, let's air seal them a little better, let's put insulation in the walls, start mandating these things that made the houses perform better from an energy standpoint. They consumed less energy to heat and cool them. But we didn't really understand at the time the effect that would have on indoor air quality. Okay, so we tightened everything up. And what we did, and we've already kind of talked about this, but we limited the ability of the building to dry out. Okay, and then we also weren't venting the houses properly. So we had all of a sudden a lot of problems with mold, a lot of problems with rot and stuff like that, we've already kind of covered that. So I don't want to dwell on that too much. What we're going to get into here pretty soon is sources of poor indoor air quality. Okay, and one of those sources is what we call source contamination. Okay, you're sitting on top of a pile of uranium and it's off-gassing and containing your home. Poor ventilation is the other kind of big cause for indoor air pollution. Okay, so we're going to talk about how we can control those things, how we can mitigate those things so that we have healthy indoor air. So the first one I want to talk about is radon. Okay, and this is in the category of source contamination. Radon is a colorless, odorless, radioactive gas. Okay. And what happens is we have uranium deposits underneath us throughout the United States, but concentrated in different parts of the United States. And as that uranium decomposes, it turns into radium. And then as that radium decomposes, it turns into radon gas. Okay? And so we built our houses on top of it. It's just in the soil. And as it decomposes, it seeps into the house. And, outside it's not a big deal. It just goes up into the atmosphere. But it can get trapped in the house and we can be breathing the stuff in, okay? Radon is the second leading cause of lung cancer, okay? The fatalities, radon-related fatalities are still kind of low, relatively speaking. I think the last number I saw was there's about 21,000 fatalities due to radon exposure, okay? And cancer caused by radon exposure. And like I said, it's all over the United States. It's all over the world, but concentrated in different parts. And we have a pretty good idea of where we need to be concerned about radon. So this little chart here I think is helpful. As far as radon levels in the home, radiation is measured in picocuries per liter. Okay, 2.7 picocuries per liter is the average amount of radon inside a home in the United States. Okay, at 4 picocuries per liter, you are required to mitigate the amount of radon in your house. Okay, and I think this is interesting. If you have a radon level of 4 picocuries per liter in your house, it's equal to 200 chest x-rays per year or 8 cigarettes a day. Okay, we jump up to 8 picocuries per liter and that amount doubles. If we have radon levels of 20 picocuries per liter in our home, that's the equivalent of 1,000 chest x-rays per year or 40 cigarettes per day. Okay, so very damaging to the lungs. Okay, this pie chart gives an idea of where we're going to come across radon. Okay, and the biggest place that we're going to find radon is in the dirt around the house. Okay, almost 70% of that. It's in water, it's just in the air, it's in building materials, it's in public water supplies. But as you can see, we don't have to be too concerned about it. Zone 3, this yellow zone, the average indoor radar screening level is less than 2 picocuries per liter. Okay, we don't have to worry too much about it. The upper Midwest, the Northeast, these are areas of very high concentration, and it's common, like in commercial areas and stuff like that, to just have radon monitoring stations. Okay, it's common to be doing testing in your home to see if there's radon contamination in your home. Okay, and then I would say generally, as far as areas where it's going to be concentrated in the house, in the crawl space, in the basement, okay, anything that's closest to the ground, obviously is going to have more radon seeping into it, but you can have that contamination anywhere in the house, okay, and the idea is to vent that out of there if you do have radon contamination. The health effects of radon are similar to it causes lung cancer, okay, so kind of the warning signs are you can start having shortness of breath, persistent cough that doesn't go away, coughing up blood. And what happens is that radon, if we're not dealing with it properly, will build up inside the house. We're breathing it in. It gets mixed with dirt and other particulates, and we breathe it in, it gets trapped in our lungs. And essentially what happens is we have radioactive gas that's just emitting radiation inside our lungs constantly. Okay, and so that constant radioactivity causes lung cancer. Okay, and like I said, about 21,000 people a year are dying of lung cancer from radon. So if you have radon contamination in your home, this chart here, this picture is a good picture, and it shows how to deal with that radon contamination. Okay, this is a picture of a slab, and it's pretty straightforward. You set a pipe in the slab. That pipe goes all the way up the house and vents out the top of the roof. Okay, so this pipe's embedded in a layer of gravel, then there's plastic over all of that, and then you pour the slab on top of that. Okay, so any of that gas that is kind of getting emitted from the soil underneath your house, instead of slowly leaking up through the gravel and then leaking up through cracks in the slab and then into the house, it's just going to take this easy path and go into this pipe. Okay, the fact that it's vented out here is going to be kind of be drawing gas into that pipe and then emitting it out of the house. Okay, you can get radon test kits. Okay, I had to order one. I didn't even know this was a thing until a few years ago. I started looking into this, but I thought, radon, never heard of it. I should look into this and get a radon test kit. And was basically inconclusive because the levels were so low. Okay, so what it is, it's a little test kit, and it's got some charcoal in it. You kind of break the thing open, you set it out in your house for a couple days, package it up, mail it in. Part of the purchase price of this test kit is the cost of having it analyzed at a lab. So you can send it off to the lab, they'll analyze it, send you back a letter saying, you got to do something about this, or it's not a big deal. Okay, and the letter I got was basically, you have levels below 2 picocuries per liter. So I don't know if that means they don't even get results if it's less than that, or I don't exactly know, but it wasn't a big deal. And then when it's below 2 picocuries per liter, from what I understand, it's difficult to mitigate beyond that anyway.